All right, now in class, we've talked about glycolysis as part of cellular respiration. And glycolysis in organisms that use oxygen is then followed by pyruvate oxidation, the citric acid cycle, and oxidative phosphorylation. But what happens when organisms do not use oxygen? What do they do, especially with the NADH? And this is the focus of your lab this week, so I thought I'd quickly go over this process. So ATP without oxygen, there's anaerobic respiration, and that's used by some organisms that uses a sulfate ion as a final electron acceptor instead of oxygen. And since we haven't talked about electron acceptors, this probably doesn't mean much to you yet. But what I'm going to focus on is fermentation. So in fermentation, this is where it doesn't use an electron transport chain and it doesn't use oxygen. So fermentation includes first glycolysis. So glycolysis, as we discussed already, produces two net ATPs. There is going to be the investment phase in which you use two and a payoff phase in which you get four. But the net is 2 ATP. And it's produced 2 NADH from an oxidation reduction reaction. And that one glucose molecule has, by the end of glycolysis, been converted to 2 pyruvates. Okay, so now what we're going to discuss is the reactions that degrade pyruvate. So pyruvate is going to get broken down even further. And again, this is without the need for oxygen. And in this process, that NADH, which would be so useful if oxygen could be used because the electrons are eventually transferred to the mitochondria to produce more ATP, in organisms or in processes in which the pyruvate needs to be processed without oxygen, there is a need to regenerate the reduced form of NADH to the oxidized form again of NAD+. And there's two ways to do this. One that is going to involve producing a product which includes alcohol, and this is called alcohol fermentation. And the second type of fermentation is one that will end up producing a product called lactic acid, and this is called lactic acid fermentation. So let's take a look at alcohol fermentation, which is the focus of your lab this week. So in alcohol fermentation, remember first, glucose via glycolysis has been converted to 2 pyruvates. Now, the next step in the fermentation process, so these 2 pyruvates are going to be broken down in a 2-step process, first to acetaldehyde, and then each acetaldehyde will be broken down to a molecule of ethanol. So let's take each one at a time. So pyruvate is going to first be decarboxylated. Do you see this carbon dioxide that's being released? And it's going to produce 2 acetaldehyde. And note that this is only a 2-carbon compound because it's lost one of the carbons for each pyruvate molecule in the form of carbon dioxide. So alcohol fermentation, as one of the products, releases carbon dioxide. Then these 2 acetaldehyde are going to be reduced to 2 molecules of ethanol. And this is the process that is an oxidation reduction reaction. As the acetaldehyde is reduced to ethanol, that NADH is going to be oxidized back to NAD+. And this will make it available for further glycolysis reactions. So overall, alcohol fermentation is going to allow the production of, it will break down pyruvate into carbon dioxide, which is a gas, and you'll be studying that in lab, and ethanol. And in addition, it is going to then recycle that NADH into its oxidized form, NAD+, so that it can be used once again. So let's take a look at this process in action. This is yeast fermentation, and I want you to take a look and see what's going on. So as the yeast is going through this fermentation process, that pyruvate is being broken down, and now you're getting carbon dioxide gas that's being released from this process. And you'll be studying this in lab this week, and you'll be looking at this carbon dioxide production, and you'll be measuring it as a function of the fermentation process. All right, now another kind of fermentation that can occur, and this can happen in bacteria as well as in your own muscles when they do not receive enough oxygen. They have to recycle their NADH to NAD plus this way, is with lactic acid fermentation. And in lactic acid fermentation, it begins the same way as alcohol fermentation in that glucose, via the process of glycolysis, produces two molecules of pyruvate. And in this process, it made 2 net ATP and a couple of NADHs. Now, the pyruvate is going to be broken down in a single step to lactate. Lactate and lactic acid are the same thing. One is just the ionized form, and so don't get confused by that. If you call this 2-lactic acid, I'm fine with that. So pyruvate is going to be broken down to lactate. And this is an oxidation reduction reaction. So the pyruvate is actually reduced to lactate. And notice there is an error on the notes. Please cross out oxidized and put in reduced. And in the meantime, NADH is going to be oxidized back to NAD+. And so that will be restored so glycolysis can continue, again in the absence of oxygen, to produce this small amount of ATP.